In sterile manufacturing and also non-sterile, cleanrooms are the areas in which manufacturing takes place and toward which the environmental monitoring program is directed, as we will discuss later on. Some of the characteristics of cleanrooms are: they are designed in a manner to minimize the generation and retention of particles. Cleanrooms are designed and maintained to limit the number of particles per cubic meter. Cleanrooms are classified according to the number and size of particles permitted per volume of air. Their classification is based on their capabilities and intended applications. The common standard for the classification of air cleanliness in terms of concentration of airborne particles is outlined in ISO 14644. For cleanroom classification, the total number of particles ranging from 0.1 microns to 5 microns are measured within 1 cubic meter of air inside the room. This measurement is performed both at rest and in simulated operations. According to ISO 14644-1, there are 9 classes of cleanroom cleanliness, ranging from ISO 1, the cleanest, to ISO 9, the dirtiest. An ISO Class 5 cleanroom is a space that meets the maximum permitted total particle concentration of 3,520 particles per cubic meter for airborne particulate at 0.5 microns in the in-operation and at-rest state. EU classifies cleanrooms in 4 classes, from A to D. According to EU GMP Annex 1, Grade A areas are required in critical zones for high-risk operations, such as aseptic processing. Grade A from EU GMP Annex 1 is equivalent to ISO Class 5. ISO Class 5 and Grade A are equivalent to the US Class 100. Now, let me explain the meaning of at rest and in operation. At rest refers to a room with the main manufacturing equipment installed, but not operating and no personnel present, while at operational means with the maximum number of personnel present performing or simulating routine operational work. It is the worst case, which is essential for routine assessment. In the following slide, you can see the current cleanroom classification according to the acceptance criteria of particles per cubic meter at 0.5 microns. In sterilization by filtration, microbes are removed rather than killed, making it a cold method of sterilization. When solutions and liquids cannot be sterilized in the final container, they can be filtered through a sterile filter of nominal pore size of not more than 0.22 micron. The filter is able to remove particulate matter, bacteria, and molds. However, filtration alone is not considered sufficient when sterilization in the final container is possible. To avoid the potential risks of filtration method, a double filter layer or second filtration through a further sterilized retaining filter is used immediately prior to filling. The final sterile filtration should always be carried out as close as possible to the filling point.